Okay, so I would now like to begin with chapter 10, which talks about multicollinearity, which is one of the most important assumptions of the classical linear regression model, that I should have no multicollinearity. So it's more or less it's an application based chapter, but it involves a lot of theory. So what is multicollinearity to begin with? So if I have to talk in terms of vectors, multicollinearity would basically mean that I can represent, so supposedly I have certain vectors x1, x2 and xn. So these are my vectors that I have. So multicollinearity would mean that I have a relationship which is like this, which is lambda 1 plus lambda 1 x1 plus lambda 2 x2 and so on, plus lambda I xi is equal to 0. So if I can so even variables, if I can represent this relationship, then I say that I have perfect multicollinearity. This is perfect multicollinearity, right? So for example, just see this. Supposedly I have 1x plus 1x1 plus 2x2 equal to 0, which means x1 is equal to minus 2x2. If I can represent this, it's perfect multicollinearity, right? So in this case, I cannot actually find out my betas. So the betas are indeterminate and the standard errors of these betas are infinite. So how are the betas indeterminate? Let's see that. Okay, so to take an example of a 3 variable case, supposedly I have y is equal to beta 1 plus beta 2 x2 plus beta 3 x3 plus u. So I know that beta 2 is given by this summation. So all this is in deviation form, remember, and the formula of beta 2 is this. So now supposedly I say that there is a perfect multicollinearity that exists, and supposedly I say that alright, my x3 is lambda x2. So just see this, that if x3 is lambda x2, then obviously mean of x3 is mean of lambda mean of x2. So I have, if I just subtract the two, small x3 is equal to lambda small x2. So even in deviation form, x3 is lambda x2. So if I have that, I can just substitute instead of x3 lambda x2 and get this. And if I try solving, this becomes a 0 by 0 form, and this is nothing but an indeterminate form. So I do not get actually any value of beta 2 hat. Similarly, if I talk about beta 3, I get indeterminate form. So I can say that, okay, because I am getting an indeterminate form, I can clearly say that there is no value of beta 2 hat and beta 3 hat. Similarly, I can take this argument further and extend this argument saying that if there is multicollinearity, then I can actually not find the values of all the variables. So take an example of that. Supposedly I have this and I know that x3 is lambda x2, then I can say y is equal to beta 1 hat plus beta 2 x2 plus beta 3, and instead of x3 I can write lambda x2 plus u hat, and this becomes beta 1 hat plus x2 beta 2 hat plus lambda beta 3 hat plus u hat. So this becomes some new variable, say alpha x2 plus beta 1 hat plus u hat y. So then you can clearly see that I actually just have a 2 variable case. I no more have a 3 variable case. I just have y is equal to beta 1 hat plus alpha x2 plus u hat. So I will no more be able to estimate beta 2